Introduction to structured cabling. It is the design and installation of a cabling systems that will support multiple hardware user systems and be suitable for today's needs and those of the future. For example, Cat5e, Cat6 or Cat6a can be part of a bundled structured cable design cable, thus providing the infrastructure to connect a phone, PC, CCTV camera, Wi-Fi, TV or music server. In this instance, all by just plugging in differently at the main cable area, where all the cables originate from. Why is structured cabling important? Without a cabling infrastructure that is structured for all technology, your future growth will be limited. Indeed, one of the biggest examples of this is old telephone wiring for PBX systems that now need upgrading for VoIP. Legacy CCTV cabling and Wi-Fi cabling is also increasingly being required to be changed recently, due to increase in technology and surpassing old cabling standards. Data cabling standards. The data cabling systems is administered under a guideline of set cabling standards, so that installations follow a consistently of installation and quality with an allowance of expansion and coverage of the technologies it is installed to link and operate. The standards cover a range of expectations such as how the cabling should enter a building and be terminated, the type, construction and size of the entrance facility, the construction and size of the communications room and cabinet, the number of cables to allow per user and workspace area, the containment allowances for these cables, installation and terminating guidelines for the cables, testing and labeling expectations. Network cabling design. What is structured cabling in networking design based on? The correct design of the structured cabling will provide predictable performance and aid future expansion. Furthermore, assist in easier future relocations, moves and changes. In essence, it's looking at the cabling design, like an architect would do with a building or home, and see how best to bring all the required elements together and work as one harmonious system. If the cabling is lacking in design, the technology systems will lack in performance and operation. The design will consider whether to cable directly to each location where desks and furniture are not expected to move, or whether to cable to distribution points which then link locally to desks, allowing for easier future moves and rearrangements of desks and furniture. The structured cabling system should cover all elements of the building hardware and technology requirements, and bring them all into a central design. This design would include the cabinet space and locations, and whether they are in a single location or split over several floors, and how the various locations are linked, whether via copper or fiber optic cabling. The containment and spaces that the cabling will travel through will also be a design consideration. The cabling must be correctly contained and supported to enable longevity and performance. The structured cabling spaces and containment must also allow for future growth of additional cables to travel through these areas. 40% fill on initial install, and 60% maximum fill is the BICSI standard. For example, categories of cabling. Structured cabling can consist of a single specific standard of data cabling, such as Cat5e, Cat6, Cat6a or fiber optics. It also in some cases will specify different categories of cable, dependent on what has been requested and specified by each hardware provider. The differences in cable could be a requirement to meet termination practices, containment limitations or installation costs. The overall design could call for Cat6a data cabling to desks for PCs and phones for 10 gig, Cat6 for CCTV, Cat5e to access control and dual Cat6a to Wi-Fi. The best solution would be to cable the overall solution to the highest standard cabling category, so that in the future all systems could work off the same data cabling, but the other considerations of containment and cost are also important to take into consideration. All hardware has a bandwidth and speed requirement, for which the correct data cabling infrastructure must be installed, to enable that hardware to perform at its required levels and work as required. An example would be a requirement for a 10 gig connection at 80 meters, which would require a structured cabling system of Cat6a cabling to be installed, as Cat5e and Cat6 would not support these transmission requirements. Importance of data cabling testing. Structured cabling also outlines a consistency of termination, testing and labeling. There are several standards of terminations when it comes to copper data cabling and fiber optic data cabling. Problems arise if different standards are followed by different installers. Thus, over an ongoing timeline, users will find that certain outlets don't work when moving hardware. In this instance, because the ports are wired to a different termination standard. Testing parameters and standards are also important, as without fully tested data cabling results, the end user will not know if that cable has been installed correctly and within the maximum distance, installed in the correct separation distances and bend radius, been terminated correctly both ends, has been tested and confirmed to work to a set standard of transmission tests. Without these test results showing full passes, the user will find problems in their hardware performance in the present and ongoing into the future. Structured cabling labeling. The consistency of labeling is also a very important part of a structured cabling installation. The labeling should be designed in advance and follow an easy-to-follow outline. The labeling should specify some or all of the following: the cabinet or floor number, the outlet number, the floor box or cluster number, in some cases. Different floors or cabinets will also at times have different color outlet labels and panels. An example would be a blue label marked 3 by 15 by 4. Third floor, floor box 15, outlet number 4. Structured cabling documentation. What is structured cabling in networking, when it comes to the correct documentation? The completed data cabling system should be accompanied by the test results, and a full set of drawings and documentation. This will depend on the size of the building and the requirements of the end user, but can consist of the following: marked up drawings with outlet numbers for each location, communication cabinet layouts, floor-to-floor cabling schematics, test results, manufacturer data sheets. As hardware changes rapidly, and the data cabling requirements to those change with them, a focus on a structured cabling systems, rather than quick cabling requirement only for the present, is becoming more of a necessity. Power over Ethernet requirements have changed immensely, and the cabling requirements to handle these data and electrical requirements will exceed legacy cabling installations quite quickly. With a focus on data cabling design, and then implementing a correctly installed system, your requirements of today and of tomorrow will be catered for, and whatever hardware you choose to add or change will be supported.